Alright guys, so let's go ahead and continue with example 2. And so we're going to convert these radians to degrees. Alright, so to convert radians to degrees, we said that we wanted the pi's to cancel. So I'm going to go ahead and rewrite these problems just to make them look better. I'm going to make that negative pi over 2. Now, I want the pi's to cancel out. So I'm going to put the pi on the bottom and the 180 degrees up top. And so when I do that, the pi's are going to cancel out. And so then if I multiply straight across, I'm going to have negative 180 degrees divided by 2. And so you can just plug that in your calculator. And so if you do that, this should end up being a negative 90 degrees. And that should make sense because we already said that pi over 2, okay, was just going to be 90 degrees. And since this is negative, this is also negative. All right. So then 9 pi over 2. If I convert that, that's going to be pi in the bottom, 180 degrees in the top. My pi's are going to cancel, and so I'm going to do 9 times 180 divided by 2. And so then if I do that, that should end up being 810 degrees. Alright, next one. So I'm going to take negative 13 pi over 4, multiply by the same thing, 180 degrees over pi. My pi's are going to cancel out, and so this is going to mean I need to do negative 13 times 180 divided by 4. And so if I do that, I should get negative 585 degrees. Now, the last one is just a little bit different, and it's different because I don't have a pi in it. It's still in radians. Unless you see a degree, you can assume it is a radian. So this is a radian because I have no degree. And so I'm going to do the exact same thing that I would normally do and multiply by 180 degrees divided by pi. And so all that's going to mean is I just multiply straight across like normal. So I'm going to say 2 times 180, that's going to be 360 divided by pi. And so in my calculator, whenever let's go bring up our calculator. So whenever I plug this in the calculator, I'm going to actually use the pi button to get a decimal, okay, and divide 360 by that decimal that it'll have. Okay, so let's go ahead and plug this in. So I'm going to go to my home screen and just type in 360 divided by, I'm going to hit second pi. And so then I'm going to round it to, let's round it to one decimal place. So I'm going to round this to 114.6 degrees. So this is 114.6 degrees. So even if you don't have a pi in your radian, you can still turn it into degrees. Okay, same difference. Alright, now let's look at telling what quadrant the angle lies in. And so you guys should have heard the word quadrant before. And so quadrants are just the 4 areas that you get that are created by the x and y axis. So this is going to be quadrant 1, this is going to be quadrant 2, this is quadrant 3, and this is quadrant 4. And so in order for me to tell what quadrants these angles are going to be in, it's probably easiest for me to turn them into a degree first. So I'm going to say 5 pi over 4. I'm going to multiply. I want the pi to go away, so I'm going to put the pi on the bottom. And so when I do that, the pi's cancel out. 5 times 180 divided by 4. Divided by 4 is going to be 225. So this is just 225 degrees. So I'm always going to start my angle on the positive x-axis. And since this is a positive angle, I'm going to rotate up or counterclockwise. And so this would be 180 degrees, this would be 90, I don't know why I did those out of order. This would be 270, all the way back around would be 360, and this is 0. So if I rotate that ray all the way to 225, I'm going to end up somewhere right here. And so that angle is going to be in quadrant 3. And so that's all you have to write for that answer is just Q3. Now let's erase this angle and find the next one. So 11 pi over 3. I'm going to take 11 pi over 3, convert it. Okay, pi's cancel, and I think you guys can probably do that math in the calculator. So this is going to be 660 degrees, and so I want to see what that's going to end up being. Now this is over 360 degrees, so I want to see how much over it is. So I'm going to go take 660 and subtract 360. You should be able to do that in your head, but it's 300 degrees more than one full rotation. So if I'm rotating this, then I'm going to go all the way around to get to 360, and then I've got to go 300 more degrees to get to 660. So 300 more degrees would be past 180, past 270, somewhere around here would be my angle. And so that would fall in Q4. Okay, so we've done two positive angles. Let's go and do negative angles now. And so I'm going to erase this, draw my standard position back there. And I'm going to erase this 90, 180, 270, and 360 because whenever I rotate down, that's going to change the way I'm going to label this a little bit or think about it. So if I rotate down, this would now be negative 90, this would be negative 180, negative 270, and then finally negative 360. And so negative 4 pi over 3, if I convert, I'm going to multiply by 180 over pi. Pi's cancel. And so the negative 4 times 180 divided by 3 is just going to be negative 240 degrees. And so when I rotate this around, I'm going to rotate it down this way. So negative 240 would go past 180, not past 270 though, so it would be in quadrant 2. Now, the quadrants don't change. So the quadrants stay the same. The only thing that changes, or you have to think about differently, is like the negative 90, negative 180, negative 270. So quadrants are going to stay the same. Last one. Let's do 25 pi over 6, or negative 25 pi over 6. I'm going to multiply that by 180 over pi. And so then my pi's cancel, and if you do that math, you should get negative 750. So negative 750 degrees, that's definitely bigger than 360. So if I'm drawing this, let's erase this thing. I'm going to draw it with blue. Alright, so negative 750, I want to find out how much more than 360 that is. So if I go all the way around, that's 360. So 760, actually we know that 720 is like 2 full things around. So I could just subtract 720, but let's just go ahead and do it this other way. So 750, if I subtract a full rotation, I've still got 390 to go. If I subtract another rotation, I only have 30 to go. So I went one rotation, here's 2 rotations, and so after I do those 2 rotations, I'm at 720, I've got to get to 750, so I've got to go 30 more degrees down. And so that's going to be somewhere right there, and so that would fall in quadrant 4. Alright, so that's how you would do that. Now, we want to talk about that slide that we skipped just a bit ago, and that is the coterminal angle slide. Alright, so the definition of coterminal angles, these are just angles with the same initial and terminal side, so the same starting and ending side. So the main thing that you need to know is these represent the same angle, okay? One angle can have a whole bunch or infinitely many coterminal angles. And so let's just look at an example with angles that would have the same initial and terminal side. So I'm going to look at an easy one. So let's put our standard ray there. And so I'm going to look at the angle 90 degrees. And so we know that would be right there. So I took the blue ray and rotated it around right there, and that gave me 90 degrees. Now, an angle that would be coterminal to that, okay, it would have the same initial and terminal side, would be an angle that I would get by rotating this ray down and around up to there. So it has the same initial, the same terminal, and so even though it has a different measure, that's going to have a different measure, it's going to be negative. So this would be negative 270, okay, if I went all the way up to that 90 degrees. So even though these have different measures, they are really just representing the same angle. And so these are going to come in handy whenever we start evaluating trig functions, sine, cosine, and tangent, secant, cosecant, cosecant. We'll talk about that later. But these will come in real handy then, so you need to be able to find them now. Now, one way that I would find this, I would take 90 and I could subtract 360 to find that. So I'm going to take 90 minus 360, and that would give me 270. So that's one way that I could do it. Now, another coterminal angle to 90 degrees. Let's erase this negative 270 here. Another coterminal angle to 90 degrees would be an angle that I would get by rotating all the way around and then 90 more degrees. And so the way I would find the measure of that angle is by taking 360 and adding 90. And so that would be 450. So 450 would also be coterminal because it has the same initial and terminal side. They have different measures, but they represent the same angle. All right. So we are just basically, we can see from this example that we're either going to add 360 or subtract 360 to find coterminal angles. And so you can do that really easily with degrees, so I'm not going to do a whole lot of examples with that. But it may be a little harder to do it with radians. And so I'm going to do this one with you, and we already saw what we needed to do from the last example, so I'm not going to look at the graphs on this one because you don't really need to look at the graphs to find coterminal angles. But we can see from the last example that we only need to add or subtract 360 to a degree measure. But if we have a radian, 360 is a whole distance around. And the whole distance around for a radian measure would be 2 pi. So we either need to add or subtract 360 or 2 pi to find coterminal angles. Alright, so let's take pi over 6. Now, I want to find a negative and a positive coterminal angle. So, in order to find a negative coterminal angle, I'm going to need to subtract. Okay, so this is to find a negative, this is to find a positive. So I'm going to take pi over 6, and I'm going to subtract 2 pi. Now, in order to subtract those, I need to have a common denominator. And so this, in order to get a common denominator, I would need to put a 6 in the bottom here and times the top by 6. So that's really going to make my problem pi over 6 minus 12 pi over 6. And so then a coterminal angle to pi over 6, a negative one, would be negative 11 pi over 6. Because this is like a 1 pi, so 1 minus 12 is negative 11. Now, I'm going to take pi over 6, and this time I'm going to add 2 pi. And so if I go through, get my common denominator, I'm going to put 6 in the bottom, 6 in the top. That's going to be pi over 6 plus 12 pi over 6. And so my positive coterminal angle would be 13 pi over 6. So there's our coterminal angles. Alright, now I want to find one for 13 pi over 6. So to find a negative, I'm going to take 13 pi over 6, and I'm going to subtract 2 pi. And so if I go get my common denominator, it's an ugly 6, this is going to give me 13 pi over 6 minus 12 pi over 6. And when I do that, that's just going to end up giving me pi over 6. Now, this is not a negative angle. That's not a negative angle, so I'm not done. What I'm going to do is I'm going to use this one as my positive. So a positive coterminal angle would be pi over 6. Okay? Or you could go add 2 pi, okay, to 13 pi over 6 and get another positive one that way. Either way is fine. But this one is not going to give me a negative, so I have to subtract another 2 pi. Okay, and so I'm just going to go ahead and write that with a common denominator. And so then a negative coterminal angle for 13 pi over 6 would be negative 11 pi over 6. So basically you have to keep subtracting until you get a negative angle. You keep subtracting 2 pi until you get a negative angle. Or adding 2 pi until you get a positive angle. Alright, the third one, I'm going to take 2 pi over 3, and I'm going to add, this is for a positive, add 2 pi, and so I would need a 3 in the bottom and a 3 in the top. So this is going to be 2 pi over 3 plus 6 pi over 3. And so that would end up giving me 8 pi over 3 for a positive coterminal angle. A negative, I'm going to take 2 pi over 3 and subtract. I'm just going to go ahead and write that as 6 pi over 3. And so that would give me a negative 4 pi over 3. And so those would be my coterminal angles. And we are done for the Intro to Trig lesson.